Notes 7.1 are about circles. Let's set up definitions about a circle. First definition will be for the circle itself. Whenever you draw a circle, you probably go like this. You probably go like around like that. When you drew that circle, you were trying to keep it all the same distance from a point. The center of the circle could be drawn first, and then you could try and draw the circle around the center like that. And when we have a circle, it always has a center, and you can name the center. So a lot of times I'll name it P or Q or O. So that's the actual name of the circle. Whatever letter is labeling the center, then we call it that name. So this is called circle P, or this is called circle Q. This is called circle O. Circle is the set of points equidistant from a given point. The radius of a circle is drawn from the center of the circle out to the outer ring. That outer ring is what is actually considered the circle. The center is not considered part of the circle. It's just that ring that's considered the circle. The radius is a segment connecting the center to a point on the circle. You've probably drawn a diameter before. When you draw a diameter, you're making sure a segment passes through the center of the circle. So you're connecting a point on this side of the circle to a point on the opposite side of the circle and making sure it passes through the center. So a diameter is a segment connecting two points on the circle that passes through the center. A tangent touches the circle at only one point. So here's a line that I'm drawing, and that's considered a tangent because it only touches one point of the circle at a time. A new word, perhaps, chord. A chord connects 2 points on the circle. So here is a chord, or here is a chord, or we already saw a chord in an earlier definition. This is also a chord. A diameter is a special kind of chord because it passes through the center of the circle. Our final definition is for secant. Secant is a line that intersects 2 points on the circle. So this is like a tangent line, but a tangent line only intersected 1 point. A secant will intersect 2 points on the circle. Our first theorem about circles has to do with chords of a circle. Now, when you look at this diagram, are you noticing that MN is a chord and OD is a chord? MN is a chord and OD is a chord. And we have two other segments showing here. Segment RA connects the center with that chord, and there's a right angle there. So that segment actually represents distance from the center of the circle. Chord MN has distance AR from the center of the circle. And then I could do the same thing on the other side. So segment RL is the distance of the chord from the center of the circle. How far is chord OD from the center of the circle? Its distance is RL. So that's what we're showing you in the picture here. And the theorems that we have about this are: if two chords of a circle are congruent, then they are equidistant from the center. A drawing of that would be, here's two chords, they're congruent. So since the chords are congruent, that means the distances to the center are also congruent. So since the chords are congruent, those distances are congruent. And you could turn that statement around. If the chords are equidistant from the center of the circle, then they are congruent. For example, you are given segment SA is congruent to segment SC. I will mark SA congruent to SC. RZ is 18, so the chord has a length of 18. What is the length of EO? That would be the other chord. EO is the other chord. What's the length of that chord? Well, since the chords are equidistant from the center of the circle, then they are congruent. If RZ is 18, then EO is 18. The next example, we start with congruent chords. So I'm going to take away this information from the previous example, and I'm going to mark RZ congruent to EO. We know that SC is 7. So I'm going to use the theorem that says if two chords are congruent, then they are equidistant from the center. And remember, these little guys here, SA and SC, represent the distance from the center because they're perpendicular to the chords. Means if SC is 7, then SA is also 7. The next page is practice for you. Please pause the video, work on this next page, numbers 1 through 7, then turn the video back on and check your answers. Did you use segment symbols for FE and EG? Make sure you use segment symbols. Mark QV congruent to QW. Number 4, PT is 2x minus 3. RS is x plus 6. They are congruent because they're equidistant from the center. So I can set 2x minus 3 equal to x plus 6 because those chords are congruent. Since the chords are equidistant from the center, they are congruent. So you can set the algebra equal to each other. 4k plus 2 equals 22 minus k. In numbers 6 and 7, we are given segment AB congruent to segment CD. So I'm going to mark those congruent. Those are actually chords that are congruent. So since the chords are congruent, that means they are equidistant from the center. So EF will be congruent to EG because of that theorem. EF is congruent to EG, so that means 3x plus 1 would equal 5x minus 5. And again, EF is congruent to EG, so 2k minus 11 is equal to k plus 3. Theorem number 2 is about a radius perpendicular to a chord. If a radius is perpendicular to a chord, then it bisects the chord. In the diagram on the left, we are shown that the radius, so that's the segment coming out of point L, coming out of the center of the circle. If the radius is perpendicular to the chord, then it bisects the chord. So that means segment AI is congruent to segment IE. The reverse of this is true. If a radius bisects a chord, then it is perpendicular to the chord. So I might start a math problem for you that looks like this. I'll draw a radius headed to that chord, and I will tell you that the chord got bisected. Once you know the chord got bisected, you can conclude that the radius is perpendicular to the chord as well. Let's look at our first example. Chord EY is 12 centimeters from the center of circle R. What it means to be 12 centimeters from the center is to have the perpendicular distance from the center. So draw in a radius that's perpendicular to that chord. Okay, that perpendicular distance is the distance from the center. They gave it to us as 12. We know that the entire chord is 32 centimeters long, and we need to find the radius of the circle. Right now the radius is not drawn in, and my advice to you is to draw it in from the center of the circle to one of the endpoints of the chord. So I can draw it from R to Y, or I can draw it from R to E. I just need one of them. I don't need them both. Now, since the radius that's perpendicular to the chord bisects the chord, that means there's 16 of the 32 on this side and 16 of the 32 on that side, because the chord gets bisected when the radius is perpendicular to it. So that's this first radius here. Now look what we have. We have a right triangle sitting here in our circle, and the right triangle has a leg of 12 and a leg of 16. That's a 3, 4, 5 triangle. 3 times 4 is 12, 4 times 4 is 16, so 5 times 4 is going to be 20. So the radius of the circle is 20. Now we have some practice problems. Please pause the video and try 1, 2, and 3, then turn the video back on to see if your answers are correct. Number 1, draw segment CA. What is CA? Do you recognize that as a radius of the circle? We are given it has length 10. CD has length 8. So we have two parts of a right triangle, and it looks like a 3, 4, 5 triangle. The hypotenuse is 5 times 2. A leg is 4 times 2, so the other leg must be 3 times 2, or 6. Now we are being asked for chord AB. Well, I know that the chord got bisected. Do you see radius CD is bisecting the chord? Now I know radius CD does not get drawn all the way to the end of the circle. A radius that is perpendicular to a chord bisects the chord. So the other half of this is 6 as well. So the length of chord AB is 12. Number 2, draw in segment EF. Draw in segment EG. EG is a radius of the circle. It has length 13. Chord FG has length 24. Let's draw in a radius perpendicular to that chord. If we draw one in, we get a right triangle, and we bisect the chord. So if the whole chord was 24, then each half of it is 12. This is a 5, 12, 13 right triangle. Chord FG has distance 5 from the center of the circle. Number 3, chord PR is 8 units from the center. That means if you draw in the perpendicular radius, it has length 8. PR has a length of 30. So the perpendicular distance that was just drawn in bisects this chord, and we have 15 on this side and 15 on that side. The radius of Q can be drawn in. You can draw QR or you can draw QP, so just draw one of them. Perhaps you could tell that's a special right triangle then in the circle. The legs are 8 and 15, so the hypotenuse is 17. Number 4, find the length of a chord that is 12 inches away from the center of a circle with radius 15. So now you have to draw your own circle. So draw your own circle and draw in a chord. The chord is 12 inches away from the center. So draw a perpendicular distance and label it with 12 because the chord is 12 inches away from the center. The radius of the circle is 15. Draw in one of the radii. Maybe you go on this side. And it has length 15. So look at your right triangle. What kind of triangle is that? That looks like a 3, 4, 5 triangle. We have 5 times 3 and 4 times 3, so we need 3 times 3, which is 9. So this side of the chord is 9, and that side of the chord is 9. So the length of the chord total is 18. Number 5, we're drawing a circle. Put the center there. Find the radius of a circle with a chord 30 centimeters that is 8 centimeters away from the center. So I'll draw a chord. It has length of 30 centimeters. I forgot to put inches on the last answer, so put inches up there on the last answer. And it is 8 centimeters away from the center. So draw the perpendicular distance and label it with an 8. That perpendicular distance just bisected the chord. So how much is on each side of the chord? Okay, we've got 15 on this side and we got 15 on that side. So if you draw in the radius, you create a right triangle with legs 8 and 15. So the radius of that circle is 17 centimeters. Okay, pause the video and try number 6 without me. Turn the video back on and check your answer. The answer to number 6, draw in a circle and the chord is 18 centimeters long. The radius is 41. Draw in the distance from the center. Draw in the perpendicular distance. That just bisected the chord. So there's 9 on this side and 9 on the other side. Now look at your right triangle. Your right triangle has a hypotenuse of 41 and it has a leg of 9. Do you recognize this triple? This is a triple. The other leg is 40, so the answer is 40 centimeters. The distance of the chord from the center is 40 centimeters. Number 7, you are given circle G, so we know G is the center of the circle. That's the name of the circle given to us up there. BG is equal to EG. Mark segment BG congruent to segment GE. And that means we have equidistant chords. The two radii are congruent and they're perpendicular distances out to the chords. So that means the chords are equidistant from the center. If two chords are equidistant from the center of a circle, then they are congruent. So AC is 2x plus 6, but DE is 3x minus 7. Now DE is not the full length of the other chord. I'm going to label the rest of it as 3x minus 7. You could have just taken 3x minus 7 and times it by 2 to get the whole length of DF. That's your choice. We need to solve for DF, so we're going to let chord AC equal chord DF. The algebra for AC is 2x plus 6. The algebra for DF, I'm going to use 2 times 3x minus 7. If I distribute, I get 6x minus 14, and then solve for x. I know x is 5, and I'm trying to find df. df is 2 times 3x minus 7. I will substitute 5 in for x, so that's 3 times 5 minus 7. 3 times 5 is 15, minus 7 is 8, and 2 times 8 is 16. Number 8, you are given circle S. That's what this notation means. And that also means that S is the center of the circle. We are given the length of AH equals the length of VI. I'm going to mark this chord AH congruent to this chord VI. If two chords of a circle are congruent, then they are equidistant from the center. What does it mean to be equidistant? It means you have two congruent segments. SC represents the distance of the chord from the center S. SE represents the distance of the chord from S. So I'm marking segment SC congruent to segment SE. The radius of circle S is 17. Draw in a radius AS and label it 17. We also get CS is 4x plus 3. So I have algebra on CS, and then we're given SE is 7x minus 6. From that algebra information, I can use the 4x plus 3 equals 7x minus 6 because those segments are congruent. 4x plus 3 equals 7x minus 6. X equals 3. Now I can find the length of SC. So SC will be 4 times 3 plus 3. That's 12 plus 3, which is 15. I know that SC is 15 now. That's a leg of the right triangle. 17 is the hypotenuse of the right triangle. So this is an 8, 15, 17 right triangle. And if I need to find the length of AH, that's the whole chord. 8 is labeling half of it. A to C is 8, so C to H is 8, for a total of 16. So the length of AH is 16.